everyone, welcome back to my channel. This is Milee. So in today's video we are going to see about the pressure belts of the earth. Before jumping on the topic, let's first see that what is air pressure. A pressure exerted by the air on the surface of the earth is known as air pressure. The air around you has weight. The air around you has weight and it presses against everything it touches. That pressure is called as atmospheric pressure or air pressure. It is the force exerted on a surface by the air above it as the gravity pulls it to the earth. So the pressure, the force exerted on the surface of the earth by air, because the gravity of earth pulls it towards the earth or pulls it towards downwards. Now we know what is air pressure. Let's see pressure belts of the earth. So on the earth's surface there are 7 pressure belts, namely equatorial low, 2 subtropical highs, 2 subpolar lows and the 2 polar highs. Except for the equatorial low, the other form matching pairs in the northern and southern hemisphere. It means that 2 subtropicals are there, one in the northern and one in the southern hemisphere. 2 subpolars, one in the north, one in the south, and polar, one in the north and one in the south. There's a pattern of alternate high and low pressure belts over the earth, so we'll see what is that. This is due to the spherical shape of the earth. So the pattern of high and low pressure belts over the earth is due to the spherical shape of the earth because it is tilted on its axis, and that is why different parts of the earth are heated unequally. So we know that the equatorial region, which is 0 degree, receives the greatest amount of heat throughout the year, and because the sun rays falls directly on it, and that is why the warm air being light on the equator rises, because we know that warm air is lighter and it rises, and the cold air is dense and it sinks down. And we also know that temperature is inversely proportional to pressure. If temperature is low, then the pressure is high, and if the temperature is high, the pressure is low. We know this thing. So warm air being light at the equator rises, creating a low pressure area there. At the poles, the cold heavy air causes pressure to be created. It is also due to the rotation of the earth. At the poles there is cold air, so temperature means the temperature is down, so the pressure is up. If temperature is low, then the pressure is high. And in the subpolar region around 60 degrees to 65 degrees north and south respectively of the equator, the rotation of the earth pushes up the bulk of air towards the equator, creating a low pressure belt in this region. So in the subpolar region, which are 60 to 65 degree north and south of the equator, pushes the bulk of air towards the equator, and it creates a low pressure belt in the subpolar region. Now let's understand it in an easy way. So we know that this belt receives this is the equatorial region. First of all, this is the equator, which is 0 degrees, and this to this, it's 5 degrees north and 5 degrees south. And now here the point is, the sun rays directly fall here, and that's why this becomes a warm area, and that is why the air rises here, and due to the tropopause it stops to an extent, and then it turns and then goes here like this. So we know that equatorial belt is low pressure belt now, and here the molecules are present from the beginning, and again some molecules are added, means this is a high pressure belt. This is also high pressure belt because same happen here. And now we also know that the polar region, which is the 90 degrees south north and 90 degrees south, these regions are having low temperature. So we know that if the temperature is low, that means the pressure is high. So here it is a high pressure belt, and this is also a high pressure belt. Now in comparison to the polar region, the subpolar regions are warmer, and that is why these regions are low pressure belt. So from low pressure the air moves to high pressure like this. From low pressure the air moves to high pressure. From low pressure it moves to high pressure like this. Now we know that air moves like this. So these are the pressure belts of the earth. Let's name them. This is on the equatorial region, so it is known as equatorial low pressure belt, or we can also say them doldrums, because the air there is calm and it is free from breezes, and it is also known as ITCZ, intertropical convergence zone, because the trade winds converge there. We'll see about the trade winds also. This belt is 30 degrees north and this one is 30 degrees south. We can't say it tropical belt because it is 30 degrees, and Tropic of Cancer is 23.5 degree north and south, and Tropic of Capricorn also. So it is out of the tropical region. That is why we are calling them as subtropical high pressure belt. This is subtropical high pressure belt. This one is south and this one is in north. And here in 66 degrees, this is the 66 degrees here, and that 66 degrees, that are our Arctic and Antarctic circle. So here this belt is out of the Antarctic and Arctic circle, so that is why this region is known as subpolar, and this is also subpolar south and north we call them. So subpolar north, and this one is subpolar south, and this one is the polar south region, and this is the polar north region. This is 90 degrees, this is 60 degrees. And now this is known as Hadley cell. This one is known as Hadley cell, this one is known as Ferrel cell, and this one is known as polar cell. This one is polar cell. The range of Hadley cell is 0 to 30 degrees, of Ferrel cell 30 degrees to 60 degrees, and of polar cell is from 60 degrees to 90 degrees. And same in the south also. This is the Hadley cell, this is the Ferrel cell, and this is the polar cell. Now we know about the pressure belts of the earth. We know about the we know all the pressure belts, we know their names. Now let's see the planetary winds. So planetary winds are those winds which blow throughout the year in same direction. If they move from east to west, so throughout the year they will move from east to west only, and these move from high pressure to low pressure. So we know that this is a low pressure belt, this is a high pressure belt, this is also high pressure belt. So it will move like this. In this direction it will move, high pressure to low pressure. This is low pressure, like this it will move. This one is low pressure belt, from here it will move high pressure belt, and this one is high pressure belt. So like this it will move. But it's not that simple, because of the Coriolis effect, they move like this. They move in this pattern because of the Coriolis effect. Let's see what is Coriolis effect. The Coriolis effect describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances on Earth. The Coriolis effect is responsible for many large-scale weather patterns. So it is saying that because of Earth is rotation of the Earth, the air is getting deflected and changing its path, and that is why it is not straightly moving from high pressure belt to low pressure belt. It is changing its path like east to west, west to east, like that. And the Coriolis effect is responsible for many large scale weathers. Now let's pretend you are standing at the North Pole. When you throw the ball to your friend, it will appear to land to the right of him, but this time it's because he's moving faster than you and has moved ahead of the ball. Everywhere you played a global scale catch in the northern hemisphere, the ball will deflect to the right. So I'll tell you. So this one here, if we can see, it's very easier to understand it here. This is the center of a circle, and this one is the point B, and this one is the point A. Now the point B is half the point A, and here if we see the path of point A, this is the path of point A, it travels like this, and this is the path of point B, and it travels like this. Now if we start both of them at the same time, and if they cover their distances, means complete their own circle, their own path at the same time, so what we can conclude here, path A has larger point A has larger path, it is this much, and point B has this much only, but they both are covering their circle at the same time. So we know that if the things covering the larger area or the larger path in the short period of time, it is probably moving faster. Let's apply this one on Earth also. So let's assume that I am on Greenland here and you are in Europe here. So let's assume that this is point B and you are point A. Now you have to cover this much path and I have to cover this much path. But the earth is rotating and it is rotating at the same time. So we both will cover distance at the same time. But you have to cover your distance of faster than me because you have to cover a larger distance. So this is only what is known as Coriolis effect. This same happens with the air also. So this is the equatorial region where the air is like this. It travels like this, and in the subpolar regions the air is like this. Here the air is like this. And now if due to the pressure, due to the changing of the path of air, if it moves like this to here, so it will go ahead of this air. Why? Because it is having its own speed and it is more than the air which is traveling here, and that is why it will push them back and go ahead of it, and that is why it will go to the left. Same happens here, same happens this side. If this air changes its path and goes to this path of the air, so it will be deflected to the right. Why? Yes, because it is having slow speed than here. That is why this will push it away and it will go to the back. This is Coriolis effect. Now let's see on the earth. So due to the Coriolis effect here, the air traveling on the equator is faster than the air traveling on the subtropical region, and that is why this air will move like this, because it is having its own speed which is slower than the air traveling here, and that is why it will be deflected to its right, means it is moving from east to west. Same happens here, it will go like this. These winds are known as trade winds, which move from east to west. And now if we talk about here, so the air will move from west to east here. Why? Yes, the same thing is happening here. Why? Because if this air moves towards the subpolar region, so it will be deflected to the right because it is having the faster speed. Here the same will happen. It will go to the front of this air because it is having the faster speed than the air present here. Same happens here. If this part of the air goes this side, so it will be deflected to the back of this air because it is traveling. Yes, because it is traveling faster than that. Here the same happens here. This air travels like this, it get deflected to the back. Now these are the trade winds, as I told you. These are the trade winds as I told you, and these are the westerlies because they appear to be originated from the west. That is why these are known as westerlies. This is the south westerlies and this is the east westerlies. These are the easterlies, the northeasterlies, and the easterlies north and easterlies south. These also appear to originate from the east, like this. And now the south westerlies are more stronger than the east westerlies because the south westerlies are having ocean on that place, and the ocean is even, and the places of the east westerlies there are land relief features which is uneven. Here if we see, so this is the south westerlies here and the north westerlies are here. So there is a Europe and Russia, Asia, and here North America, Greenland part is there, and here totally ocean is there. Not totally, lands are there, but more part of ocean is there, and that is why it is even. And here if we see that this part of the westerlies, this one is the 30 degrees as we know, this one is the 40 degree here, 50 degree here, and the 60 degree here. So the 40s are known as, the 40 degree south are known as roaring 40s. This one, the 50 degree south are known as furious 50s, and the 60 degree south are known as shrieking 60s. here. Roaring 40s, furious 50s, and shrieking 60s. So now we know about the pressure belts of the earth, about the Coriolis effect, about the types of winds, how winds move in each belt, and name of each belt. So now let's revise them quickly. So here if we see, this is the equatorial belt, subtropical belt, subpolar, and the polar region here. In the equatorial belt, equatorial doldrums, as I told you, sun rays directly coming here, it rises, goes there, and the planetary winds travel from high pressure to low pressure, so it will again come like this. So this is the cycle goes on here, the cycle goes on here like this, the cycle goes on here like this. So this cycle continues, and here the northeast trade winds, southeast trade winds, from east to west they move, and these are the westerlies, prevailing westerlies, and these are the polar easterlies. Again they are moving like they appear to be originated from the west and the east respectively. So here, as I told you, that the equatorial region and the polar region, it is known as the Hadley cell, this is known as the mid latitude cell or the Ferrel cell, and this is known as the polar cell, from the subpolar to the polar region, and its range is from 60 to 90 degrees. It is from 30 to 60 degrees, and this one is from 0 to 30 degrees. Same here, it is this is the low pressure belt, high pressure belt, these are the doldrums, the horse latitude. Why we call them horse latitudes? Because the air there is very sluggish and cold and uneven and full of breezes. That's why we called them horse latitudes. And these are doldrums because the air is calm and free from breezes. So this was all about the pressure belts, types of winds, from where they move, name of the belts, Coriolis effect, and everything. So meet you in the next video. Till then, stay tuned. Bye bye.